going back to yesterday with the matrix multiplication. If you remember what we're doing is first thing is you've got to check on the sizes, write down the dimensions. Again, we're talking about the dimensions. It's the rows by the columns. And check to make sure that if you do that, then when you put the two things together, that everything matches up in the middle. And then if you do that, then you've got the answer that you're looking for. All right, yesterday we did a 2 by 2, which was all the time that we had. Today we're going to look at some that are not 2 by 2s, look at some different sizes, some different ways to kind of mix them up to go through this thing. So let's say that X is 10, 1, 0, 9. And this is 6, 0, 2, 5. All right, and then matrix Y, 6, 3, 2, 1. That's 10, 1, 0, 9, and then 6, 0, 2, 5. Yeah, scoot that 1 over for no apparent reason there. All right, so if you check your dimensions here, this one is a 2 by 4 matrix because we got 2 rows and then 4 columns. This one you've got 1, 2, 3, 4 rows, but you've only got 1 column, so it's a 4 by 1 matrix. All right, so let's see if we can find XY. All right, first thing again you want to check is to make sure that if you do X times Y, first off, it's 2 by 4 times, because there's always that options in Math Excel and even on the test, there's going to be an option of not possible. So you got to check to make sure it's there first. So again, we got 2 by 4, 4 by 1. Your numbers in the middle are the same, so we know that that's good. And your answer then is going to wind up being a 2 by 1 matrix. Okay. Again, if those numbers in the middle don't match up, then it's not possible to multiply those two matrices together. So that's the first thing you always want to do is check it. And that way you know what's going to happen. So we're going to have 2 rows and only 1 column. So we're going to have 2 answers basically stacked on top of each other. All right, and then flashing back to yesterday, the big thing is you've got to remember that whenever you're doing this stuff, it's always the row by the column. So it's the first row of X times the first column of Y. And I would say for these, try not to do it in your head, because if you do, there's enough stuff going on that if you try to do it in your head, you're probably going to wind up missing something more than likely. Okay, so first row of X and then first column of Y, because it's always rows times the columns. And then from there, you just take it one number at a time. So it's the first number here times the first number here. So that's 10 times 6. Now, that part, if you want to kind of skip it, you can, because we've got 10 times 6. We know that's going to be 60. Then we've got 1 times 3. And again, if you want to kind of skip that, you can, because that's where the multiplication should get easy for us here. We got 0 times 2, which is 0, and then 9 times 1 for 9. So we've got 63 plus 9 should be 72. Nice. All right, again, for the going with the answer, we're going to have 2 rows and only 1 column. So that's going to be the first row, first. So we know that's always going to be your first number every single time, because that's the first thing we're doing. Okay, and there's only 1 column, so we can only do that every row 1 time. So now we're going to go do the second row times the first column. It's here. So we're going to multiply the second row of X times first column. So that is 6025. And again, because there's only one column, it's going to be the same numbers every single time. It's going to be 6321. Okay, and then it's just one number times. So it's 6 times 6. And maybe one of those that you want to just, if you want to kind of scratch them off as you go through to make sure you got it. Then it's 0 times 3, which is 0. Then it's 2 times 2, which is 4. And then 5 times 1, which is 5. All right, so that's 40 plus 5, 45. So then our final answer was 72 and then 45. Okay. And again, it's got to be a 2-by-1 answer from what we had back up here in the beginning. So again, there's your 2 rows and only 1 column. So it makes it 72 by 45. Okay. So everybody right there? And the only thing that really, if there's anything complicated with this, is just keeping up with your positives and negatives. But it's just making sure that you line up this row in the first matrix and this column in the second matrix. And as long as you can remember to go back and just multiply the first times the first, and the second times the second, and the third times the third, and the fourth times the fourth, it's just a matter of just kind of, again, it's not hard. It's just keeping up with the stuff that's there. So. Is we're going to do determinants and inverses. Get back on the screen here. There we go. So first part was all multiplication. Second part, we're doing determinants and inverses, because to be able to do determinants and inverses, we got to be able to do a little bit of multiplication along the way. So we'll get the practice here with this one, as we're kind of going through the parts of it here. Okay, so when we talk about a determinant, we got the two things with determinants and inverses. So we'll talk about both of those things as we go through this part. Oh, let's see. Let's talk about this first. Yesterday we talked about the additive identity, the zero matrix, where if you add in all zeros, you got the same thing back on this one. For this one, we're going to talk about just a couple of things here real quick. The multiplicative, I always like that word. Multiplicative identity matrix, which they just let you kind of easily say, all right, we're just going to call that capital I, or just I in that case. All right, and depending on the size of the matrix, it's different one. So to be able to take, so if it's and the way they show this, and if it's and this is always for square matrices, if it's a 2-by-2 matrix, they'll put like I2. That to always get the same thing back that you're multiplying, it's not just multiplying by ones, because remember, you're going to add all the stuff together. So the way it works out for these is to be able to multiply some matrix by some other matrix to get the same thing back, is you've got to have ones basically on a diagonal. So if it's a 2-by-2 matrix, you got to multiply by 1, 0, 0, 1. If it's a 3-by-3 matrix, then it's 1. Basically, you got 1, 0, 0, 0, 1, 0, and then 0, 0, 1. So anytime we're doing multiplicative identities, it has to be a square matrix to have an actual pattern to it. If it was I4, not that we're going to go to I4, there'd be 4 numbers on the diagonal, and then everything else around it would be filled in with zeros. But we're just going to stop at either 2 or 3 just because of where we are and everything that's happening with it, and how much time it takes to work through a 4-by-4 matrix to kind of get there. Okay, so here's what they're kind of getting to, and this is where we're getting kind of leading up to everything with determinants and matrices. It's basically this. If you multiply A times B, and again, you could reverse it and make it B times A to get the identity matrix or the multiplicative identity matrix. So if you take two matrices and multiply them together, and you get this ones on the diagonal and then everything else is zeros. So if we start with matrix A, then matrix B is the multiplicative inverse of A. Yeah, so if you take two matrices, let's say if you start with matrix A and you multiply it by matrix B and you get this identity matrix that's here, then they're going to say that B is the inverse of A. Because you want it to cancel everything out, basically, is what kind of what's doing there. Okay, and how they show the inverse. It's shown by A, -1. And if y'all remember back when we did inverses with functions, if we had function was f of x, to show the inverse, we did f -1 of x. So it's still kind of holding on to that same thing, that if you start with something and you find the inverse, you put in that -1 to show its inverse. So matrices, it's still kind of doing that same thing, that we're going to throw in that -1 to show that it's inverse. Okay, so what you're going to have to do then is we're going to kind of show you what we got here. Is they're going to ask you, are A and B inverses? So this is where we kind of get to practice on the multiplication without specifically saying we're going to practice multiplication, but it's practice to kind of get there. All right, so let's say matrix A is 1, 1, 5, 4. And then matrix B is -4, 1, 5, -1. Okay, so here's what we're going to do. We just need to multiply these two matrices together and see if we get, because they're both 2 by 2 matrix, see if we get this. If we get this thing back here, they're inverses of each other. If we don't, then they're not. So this is where we get to practice our multiplication here. So we're going to do A times B, and let's just see what we get. All right, so this will be kind of a good practice for this part. All right, so for this one, so what's, in this one, I want y'all to kind of tell me, so what are we going to do here? What's the very first thing we're going to multiply? Okay, so it's the rows of A and the columns of B, right? So what's the first row of A we're going to multiply? All right, we're going to go 1, 1, because that's the first row. And then the first column of B would be -4, 5. There you go. Okay, so we're going to do 1 times -4, which is just -4. And then 1 times 5. So we've got -4 plus 5. So that's 1. So right now, and again, we know that that's always the first number in the very first corner. So the first number is good. So we're good to go there. All right, so now we've done first row, first column. Now we've also got to do first row and second column. There we go. So we're going to do 1, 1 times 1, -1. All right, so 1 times 1 is 1. 1 times -1 is -1. So that's 0. Okay, so first row, first number is 1. First row, second number is 0. So far, if we're putting answers down, it'd be 1, 0. So we'd have that. So first thing, we're good. So as long as the next two answers are 0 and then 1, then we're in good shape. And if you ever get any of those numbers along the way that's not set up like that, then you know that it's not going to be that way. Okay, so first row is done. So now we're going to second row. So now it's 5, 4 times first row, or first column. So it's negative 4 or 5. Okay, so 5 times negative 4 is negative 20. We're going to add that to 5 times 4, which is 20. So that one is 0. So there we go. So there's that 0. So as long as that last row column multiplication comes out to be 1, then we're good to go. And this is right up against the bottom, so I'm going to put it over here. So we're going to do 5, 4 times 1, negative 1. So 5 times 1 is 5. 4 times negative 1 is negative 4. 5 minus 4 is 1. So that one checks out. So we get that identity matrix where we got 1s on the diagonal. So are these two things inverses? There we go. So to check for inverses, it's just doing multiplication. So again, that's where we're kind of getting that practice still, because we're still multiplying. It's just kind of answering a question with what numbers we get to multiply there. All right, so let's check one more of those, see how we're good. And again, you're not going to get anything bigger than a 3 by 3 because at that point it just gets to be overkill. Probably two. You can probably get more 2 by 2s than anything else. Maybe one 3 by 3 that will sneak in there. So let's do one more 2 by 2 to make sure we're good. All right, so let's let A be 3, 2, 5, 4. And let's let B equal 2, negative 1, negative. All right, I'm just going to throw some people off here because I don't want you to get freaked out if you see this. Negative 5 over 2. So if you happen to see a fraction, don't freak out because, it's okay. You could change to now as long as it's now in that case you could change that to negative 2.5 if you'd rather do that and use a decimal, that's fine. But make sure it's something that's terminating decimal. If it's like 5 over 3, you can't do that because it's 1.6 repeating forever and that's going to mess things up. So if it's something that you can actually terminate, make it negative 2.5, that's fine if you want to do that. All right, everybody get that we're doing rows times columns. All right, so we're doing row times the columns. And you may even just kind of want to do that where you're not rewriting everything. So now we're doing 3 times 2, which is 6. And then 2 times negative 5 over 2, where the 2's will cancel. So that's 6 minus 5. So that's 1. Okay. And if you kind of do it that way, you can almost kind of place where everything's going to be. So here's our first row, first column. So we can put this answer here. If we do first row times second column and put that answer here, it's kind of where the answer should be. So it'll be here. So we kind of leave it that way. So it's 3 times negative 1, which is negative 3. And then we've got 2 times 2, which is 4. And that's 1. And we don't have to go any farther because that's got to be 0. So A and B, are they, and I didn't put the question back here, which would have been nice, right? Are A and B inverses? Always helps know what the question is, right? Yeah, kind of forgot that. That's kind of important. In that case, that's going to be a no. Because again, if that's going to be an inverse, that number has to be a 0. And if it's not, then you don't have to go any farther. You can just kind of stop right there.
So could it be 0, 1, or does it have to be 1, 0?
No, first number here, this very first answer here, when you do the first row times the first column, that always has to be 1. So if that's anything other than 1 there, then you don't have to go any farther. You can stop right there. So and then after that, every other number after that would have to be 0. If it were doing like 3 by 3s, and if you did if this was a 3 by 3 matrix, it would have to be 1 0 0. And then when you start the next one, it would have to be 0 1 and then 0. And then the third one would have to be 0 0 1. So you always got to have a 1 only on the diagonal, kind of going that route. That's got to be, if it's 2 by 2 matrix, it's got to be this answer. If it's a 3 by 3 matrix, it's got to be that answer if you're going through those. Okay, so there's one that is and there's one that's not. And again, you're basically looking that this thing would have to be 1 0 0 1 for answers to kind of get there. Okay, so that's doing inverses, and we're going to do a little bit more with inverses. But before we do that, let me back up and get one other thing here, because we're going to actually use the inverses to kind of help us figure out some stuff. All right, here's the other new definition. Determinant. All right, the good thing is they let you kind of do this short. So they're writing determinant every time they're going to do it for short. They'll just do DET. All right, and for when we're doing determinant, it has to be a square matrix when we're going through these. If it's not a square matrix, we don't have to worry about it. Okay, for 2 by 2 matrices, it's really pretty simple. So let's just do this way. So let's say you have matrix A, and just so we don't worry about the numbers here in a second, but if matrix A is ABCD, then the determinant of A, and we're actually going to have to, where you get to use the matrix itself, we go back with ABCD here. To find the determinant of a matrix, you're going to do cross products, but you have to do them not going down. You have to do cross products going up. So it's multiplying these two numbers together and these two numbers together, and then you're going to subtract those two numbers. So it's going to be AD minus BC. So it's cross products, but you have to go up instead of going down. If you go down, you're going to get the number in the, it's what's going to be the wrong number. Yeah, AD or DA. Yeah, so if you want to do DA minus CB, that's fine. Because again, whether you do A times D or D times A, it's still the same thing there. Just didn't know if you wanted to be, just ever how you want to do it there. Okay, so here we go. Let's give you one. So find the determinant of A when A equals 2, 5, negative 4, 8. Okay, and again, if you're looking at this on either the paper pencil test or if it's Math Excel, you've got to write the question down. So this will be one where you go back and write down the matrix. Okay, so it's these two multiplied times these two, and there's always a minus in the middle, regardless of what the signs are. So it's 8 times 2 for 16 minus negative 4 times 5 for negative 20. So it's 16 minus negative 20, which we know if you do minus negative, that's really a positive. So it's 16 plus 20. So it means the determinant would be 36. Okay. Easy enough? Okay. All right, here comes the hard one. Okay, 2x2s are easy because you do this times this, this times this. You subtract those two numbers, and then boom, and you got it.
Okay, so 3 by 2.
Yeah. So when we go 3x3, now it's the same concept, but it's a little bit different because we got to get the how in there. That's how it is. So we're gonna do a 3x3 matrix. We're not gonna do a 4x4. We're gonna stop at a 3x3.
Wait, does it just keep going?
Yes, you can go up to a 5x5 or a 6x6 or 3x3 is as far. And there's only gonna be one 3x3 because it takes a little while.
Why do you do this then?
Yes, just one.
Do you do more of these and nothing?
No, you pretty much stop at 3x3 because after 3x3, it's just overkill. So if you can do a 3x3, you can extend it out to do a 4x4. So it's just, yeah. You just have to say three because there's a trick to getting a 3x3 that you don't use in a 2x2. And once you know the trick, then it works for everyone after that. So, okay. All right. So for this one, here's how we're going to do this one. I guess, well, let's do this. Now, I've seen different ways for this one. We're going to use all different letters because I've seen places that do A, B, C, but they'll make this like A1, B1, C1, and then they'll do like A2, B2, C2, and then A3, B3, C3. But let's just go ahead and use different letters because, it's easy that way. So let's make this D, E, F, G, H, and then I. Okay, so what you got to do is you have to, because right now if you start doing cross products, if you start doing cross products, that you can only do one here and one here, right? Because you don't have enough numbers or letters here to make it so that you can multiply, three numbers by three numbers. So to get it to line up so that it does that way, you're going to have to rewrite the problem with the first two columns repeated on the right of the original matrix. So what that's going to look like is we're going to take the matrix we got here, where you've got, A, B, C, D, E, F, G, H, I. And to make it line up so that we can actually find out what the determinant is you just take the first two rows you got here and just put them right beside it. So you got that. Okay, so take the original matrix, the original 3x3, and just rewrite the first. Basically, it's almost like you're going to take this and put it beside it, but you just leave off the last row when you write it over here. All right, and here's why you're going to do this. That once you rewrite it here, now you're going to do your cross products. Because if you start trying to do cross products, there's only one letter here, there's only two letters here. Now you've actually got three you could do here. So you're going to do, basically, it's going to be like A times E times I. And then we're going to add that to G, F, B. And then you got this one where you'll do C, D, and then H. Okay, so we're still keeping this same process back here where we're going to multiply, but this one there's only the one thing that's here. So 3x3 gets a bit more complicated, and that way we can actually get these parts going, and then we're going to subtract everything going in this direction. So now we're going to do GEC. We're going to add that to H, F, and A. And then IDB. Okay. Now, and again, it looks funny because we got all kinds of letters here, and it's really not so much about the letters; it's the location that you're going to go for these, and that's why a lot of times you'll see it. And again, it's seen it different ways. A lot of times when you're just looking at a matrix and like getting a definition of it, they'll show it like that, where it's like A1, B1, C1, and A2, B2, C2. It's still complicated when you look at it because if you write it like that, it looks something like this. Still got a bunch of A's and B's and C's on this thing as you're going through it, but it's still these things multiplied together, subtracted from these things multiplied together. Again, we are not going on to a 4x4 because that would be cruel and unusual punishment. Yeah, so it's they're almost like placeholders. You can think about it that way. Yeah.
So it's
GFB or BFG. Is that Big Friendly Giant? Is that what the movie was? Yeah, BFG, Big Friendly Giant. Yeah, and then CDH. And then you got a gecko, GEC, HFA, or if you did HAF, be HOF, and then IDB, Internet Database. All right, Big Friendly Giant. There you go. Or BF Goodrich if you're in tires. All right, so let's get some numbers on this thing so you can actually see what it looks like. Yeah, let me write this down first. All right, so 1, 0, 3, 2, 4, 6. Okay, so define the determinant. Again, if you got this problem written down, this was reasonable. We're going to do it just like you would, because if it was a test question, you'd have to write this problem down anyway. Write down 1, 0, 3, 2, 4, 6, 5, -1, 3. And then repeat. And again, all you're going to do is just repeat the first two columns. Now, and try to kind of keep them lined up, which sometimes is difficult. Don't space them. Try to keep the same spacing, because if you mess up the spacing, it makes the multiplying a little bit harder when you do these. So try to keep the spacing the same, for each column, even though we've got this corner off here, try to keep the spacing the same because that makes it a little bit easier when you go through these. Okay, now, without the letters, this actually is a little bit easier with the numbers because you're going to multiply 3 times 4 times 1. 3 times 4 is 12. 12 times 1 is 12. So again, numbers wise, it's actually easier than if you have the letters because the letters get confusing because you got a bunch of letters. Then it's going to add that to 5 times 6 times 0, which is 0. And then -1 times 2 times 3, which is -6. So you won't use this little triangle here or this little triangle here when you're multiplying going this way because you just need those numbers there. All right, now when we turn and go the other direction, again, it's going to be minus, and then all these numbers. So we're going to go 5 times 4 times 3. 5 times 4 is 20 times 3 is 60. Then it's -1 times 6 times 1, so that is -6. And then 3 times 2 times 0 is 0. Right, so we got all this clutter in here that we've got. So basically, if we look at the red part, it's 12 minus 6, which is 6, minus 60 minus 6 is 54, plus 0, that's 54. So that's just 6 minus 54. which is negative 48. Okay. Yeah, and again, it's just a little process. And again, the math is not hard because you're multiplying, and then you're either adding or subtracting. So the math isn't hard. It's just keeping everything kind of lined up to make sure we got. Now, here's where this ties in. Here's where this is where we start tying all this stuff together. If you do the determinant of a matrix, if the determinant equals 0, then the matrix that you're working with does not have an inverse. Just like when you remember when we were doing synthetic division, that if you were doing that in synthetic division, it was actually the opposite. Synthetic division was if we did synthetic division and the remainder equaled 0, then we had a solution. This one's kind of the opposite. It says, all right, this time if the determinant does equal 0, then we do not have an inverse. You cannot find the inverse of that matrix. It does not exist for this thing. Okay, so if the determinant equals 0, then the matrix does not have an inverse. Because some of the questions will be that same way of, find the inverse of the matrix if it exists. So it's kind of the same thing of if it's possible as you're going through these. Okay, so now here's how you would actually find a matrix inverse. And this is getting us to the last thing we got to do here. This is where we're kind of putting all this stuff together. All right, so to find the inverse, let's just call it matrix A. And again, it's any A stands for any matrix. In this case, we're just going to call it A, just so we got something to call it that's here. When A is going to equal. Now, and for doing all the really now I may ask you to find the determinant of a matrix. As far as like finding the inverse, we may just stick with 2x2s because 3x3s get really complicated. So it may be one of those I may just ask you just to find the determinant of a 3x3 matrix where you're doing what we did back there. Actually finding the inverse, we'll probably just stick to a 2x2 because it gets pretty complicated when we get to 3x3s. Okay, so let's say matrix A is just like we're doing earlier. That's A, B, C, D. So if matrix A is A, B, C, D, the inverse of A, which again is equal to the A negative 1 power, or the A to the negative 1. And then A negative 1, your inverse is going to equal, and here's what you got to do. This is why we kind of go back and do the determinant. It's going to be 1 over the determinant of A and then you multiply that times. And then we'll take this matrix we've got here. You're going to switch the D and the A location. And then on the other diagonal, you make those two numbers negative. Okay, so you're going to go ahead and do the determinant like we did before. And again, as far as finding the inverse, we're going to stick to a 2x2 because a 3x3 gets really long and complicated. As long as we do 2x2s, we're good. So again, the easy part of this one is you're going to do D times A and then minus B times C to figure out what this determinant is. And then once you do that, you're going to do 1 over that number, and then you're going to multiply it by BA where you switch these two and then make these two negative, and then you just multiply this thing out. All right, so let's give you some examples of this thing. All right, so there's our directions or our steps on how to do this thing. And here's going to be our questions. Does the matrix have an inverse? And then if so, find the inverse. Okay, so the answer to the first question is, does the matrix have an inverse? Is where you have to do the determinant. And if the determinant equals 0, it does not have a matrix. Anything other than 0, we're good to go. But if the determinant equals 0, it does not have inverse. So if you get 0 when you do the determinant, you stop. There's nothing else you can do. Anything other than that, then we're actually going to go back and find this thing. All right, we'll do 1 or 2 or 3 examples and just make sure everybody's okay with it. See if we're good here. Again, these are all going to be 2x2 matrices just because we can do 3x3s, but they crank it up in the notch. We're just going to stop at a 2x2 just because where we are time wise. All right, so matrix A is 4, 2, 3, 2. All right, so step 1, you're going to take you're going to take that matrix, and you're going to do your cross product. So we're going to do 2 times 4, which is 8, minus 2 times 3, which is 6. Okay, so we got 8 minus 6. That is 2. And as long as it's anything other than 0, then yes, we do have an inverse. So the answer to the first question is that equals 0. So yes, there is an inverse that we can find. Now we have to go figure out what that inverse is going to be. All right, so for step 2, so we figure out that this is 8 minus 6.
Yeah.
As long as this number is anything other than 0, we can find the inverse. If that equals 0, you stop, you're done. There is no inverse. You can't do anything with it. Okay. All right, so step 2. To find out what the A negative 1 is, again, we're going to put 1 over the determinant, so that's 1 over 2. And then we're going to switch these two numbers. So we're going to put the 2 here and the 4 here. Oh, sorry. In my bad. Thank you. Sorry. Didn't put it up right. All right. So we're going to switch these two numbers. So we're going to do 2, 4. And these two numbers on this diagonal stay the same. You just have to make them negatives. Yeah, so we switch these two numbers. So instead of being 4, 2, now it's 2, 4. These two numbers, they'll stay the same, but you change the sign. So if they're positive, you change them to negative. If they were negative, you change them to positives. And then from there, all you do is you just do distributive property. So now it's a half times 2, which is 1. It's a half times negative 2, which is negative 1. It's a half of 3. Oh no, it's that fraction again. Pesky little fractions. Now, for these, they're probably going to make you want to leave it as a fraction just because they don't like decimals mixed in with the matrices. And then half of 4 is 2. There you go. So yes, it does have an inverse. What is the inverse? It is 1 negative 1, negative 3 over 2, 2 for the inverse.
That's all we do?
And that's all you do.
That's so easy.
We can stop now.
Can we stop there?
Yeah.
Okay.
Yeah.
Okay, look, I'm gonna have to go on another sheet of paper, and that's gonna be a waste if you're looking more.
Okay, so with this one, if you don't want to write it down, just watch, because this will be a just watch.
Okay.
All right, so for example 2, again, you do not have to write this one down. Let's say it's matrix B. It's 2, 5, negative 4, negative 10. Okay, step 1 is you're going to find out what the inverse is, or the determinant. So it's 2 times negative 10, which is negative 20, minus 4 times negative 5, which is negative 20. So it's negative 20 minus negative 20, which is negative 20 plus 20, which is 0, which means there is no inverse for that particular matrix. So you don't have to do anything else.
Oh, I see.
So that's always the first check. You multiply to figure out what the determinant is. And then if the determinant is 0, there is no way you can find the inverse because the numbers just will not match up to be what it needs to be.
Is that what you see last week?
Okay.